Hi, everyone. Isn't testing fun? Right? You know, I see some people that are the second testing talk of the day, right? That's a good start. That's a good start of a testing presentation. So I'm known as the Brazilian Java man, right? I'm known as the guy with the flag. But the truth is, there's a bunch of Brazilians that are doing amazing Java stuff. And so it's a huge honor to be here and introduce two great friends. So Elias and Tatiane Nogueira, they're not only a couple, but they are amazing developers. They've been working with tests for a long time. They're coordinators of the largest Brazilian developer conference, and they are amazing speakers. So put your hands together to Elias and Tatiane Nogueira.
Hi everyone, thanks for coming here. See Brazilians showing up some stuffs to you. Like Bruno said, we are both Brazilians. Yeah, we are a couple also. Our contact is here. If you can follow us on Twitter, on LinkedIn, or any other social networks that we can give to you. If you need to speak to us after the presentation, you are here the whole event. So just find us. We are all together all the time, so it's easy to find us. And that's great. So just one question: who here working with Java? Just Java? Oh, a lot of people. Okay, because all the code we're gonna show to you is based on Java. So Oracle codes open up for the whole all language. So Java is our base language, but all the examples here can be done in any other language. Okay, but with different frameworks, obviously, but can be applied in the same way.
Okay, our stack for this project is as program language Java, as TestNG and Selenium. As data generation, we use Java Faker. For logs and reports, we are using extent reports and log4j. And for infrastructure, we are using Docker and Selenium.
So we're gonna hear talking about some test architecture for our web test applications. Sometimes the testing is not so applying in a good way, or with some patterns or some architecture, but it's a good way to apply it for our projects. So the first thing is the base architecture is the application of the clean architecture of design patterns and testing patterns. There's not a lot of design patterns or testing architecture in general, but with a few patterns, we can create some good architectures for our tests. And we're gonna talk about page object model, the application of the page object itself, and the page factory, and all around using page objects to put the code more readable. And after, we're gonna talk about some logs in reports. Logging exceptions and log reports of our test applications, it's a must-have feature because we need to see if any test has run okay, or if not, we can get the root cause. We're gonna talk about some data generation that it's the most painless thing during the test automation. It generates the data all the time. Also, we're going to talk about the parallel execution based on containers with Docker to speed up our testing execution. And the last one is the pipeline, because we need to create some strategy to run all these tests. Obviously, we won't run it manually, so we need to apply some strategy to run it all the time automatically.
And the minimal items in the base architecture are the base test, that is an abstract class that will take care of common actions in your automated tests. The application of the factory design patterns to create our browsers for the automatic execution. And a test listener that is a non-intrusive way to know what's happening during the test execution.
So now we're going to talk about these features. There's a lot of other features that we can apply in the test architecture. So we're going to show just the base of this, and after the code, how we can create this, okay? I think all of you is familiarized with the base class or base testing class. It's the base test class is a base class that we can do a lot of common actions in your tests, like browser initialization and close, open and close database, or open and close some log files on connection to the file servers and login logout apps. So it will be used by all the tests, okay? It's a common action, it's a testing pattern to apply to our code base. So with the base class, we can use smart use of the inheritance to apply common actions to our test, and we can follow another rule that's not contained in the base test, that is create just one test for one functionality or for one action for the user, and not just many tests in just one test class. Because we need after to divide in some test suites to execute more easily our tests and create some testing strategies to execute all the tests. So the first thing here, I need to go off the presentation and go through my IntelliJ. So here we go. This base test class, in this example, just have a precondition and a postcondition. That's the open the browser and after close the browser. With of course with some class, some factories to open the browsers. So that's it. Common actions that we can apply to our tests to make our tests more readable and that duplicates all this code inside the any tests, okay? The second thing we need to do is applying the factory design patterns to create some browsers. I think it's Internet Explorer is not there because it's not a browser itself. I think Edge is a browser, but we have Chrome, Firefox, Edge, Safari, and any other browsers to use with Selenium or some other tools to automate the tests. So we need to apply these design patterns to create some parallel execution, not just a parallel execution, to create a factory to create all these browsers. Because we don't need to put hard code in your tests or browsers too. So it needs to create some strategy, and factory design patterns can do that. So the factory design patterns can help you create these browser instantiations for us, talking about automating tests for our website. Here in the code, I've created some basic factory using enumeration in Java, create some interface to apply it for all the enumerations, and for each enumeration, for Firefox headless, so Chrome headless, and so on, I have to implement that methods to instantiate the browsers. Here is the classic Selenium WebDriver instantiation for any browser. So it's make easier to create all these instances, and if I need to change some instantiations for Edge or for Firefox or for Chrome, I have just 1 point to change it all. Okay? And the last one is a feature of the test energy framework for Java. We can use JUnit as well, but this feature just is only available in the test energy. That is listener. Listener is a non-intrusive way to watch or modify something you like in your tests. Okay, it's really helpful if you need to create some reports, some logs, or do any actions during the test lifecycle. This test lifecycle may be just testing start, the finish. If a test gonna fail, gonna skip it, you can control this through the listener. So you need to apply this approach, of course, in any test you have. So if you have a base test class, we don't need to apply in all the tests. We just need to apply in the base test class that we're gonna be use the inheritance to get all these listeners for each test. The listener itself is really easy to use with test-ng. I have this a class called a test listener that implements an y test listener from test-ng, and I have the whole methods that can watch this testing lifecycle, and I can do something, whatever I can do. So here I'm doing some logs on the reports, logs and reports. When a test is going to start, I need to create a logging report for show after for stakeholders if the test is going to success or going to fail. It's going to fail, why it's going to fail, and if I have any screenshot I can attach, and so on. Notes that we can just put it inside the test listener without change of your code. I need to show which test we're gonna do. This is applying a page object. So here in the test, I just have a annotation test with a description, and the test itself without logs, without browser initialization, without any other thing that I need to apply to create this architecture. So I can just, if I need to change all the things for reporting or for logs or for browser initialization, the test maintain us here, and I just need to apply all the changes in this architecture, not in test itself.
So, a page object model is very important for the web test automation. Not just the page object itself, but the page factory that will reduce code in element initialization and waiting strategy creation. The load strategy to create a synchronous wait, and a FLUENT interface to add more readability to our tests.
Raise your hand if you know what is page object. A few ones. Okay, no problem. We are all learning in the whole life. And the page object is a class that serves an interface to a page to help to try to make some easier things to change in the test and don't apply in the whole test, just applying as a proxy, as a service between the test and my code. It's a class that provides methods to provide some actions, and we can use these actions, these methods in the whole test. So in an example, if I need to try to test a booking app for a flight ticket, I have here a search page, a flight selection page, and a payment page, okay? So what I need to do is create a class for each page first, with the method for search page to fill the airport from the operator, or in the payment page, fill the credit card, or select PayPal or Apple Pay to pay or booking flight or tickets. And I have here some tests like successful book. I can make a successful book, and successful book will use the search page object, the flight selection page object, and payment page object. If I have another test that invalidates from the search page, I just need to use the search page object. And if I had some, try to see some payment problems, I use the whole three page objects, okay? But the main point here, if I have some changes on my front end, on my search page, try to make this new or change some aspects on my front end, I have this impact of the three tests in it, but I just need to modify just the search page object, because it's gonna use this proxy, this service, to apply on the tests. We can do it, and all the benefits on applying page objects, it's make it easier to maintain our code base, okay? I have here our application it's really simple. It's for book of room. If I have here some personal details like email, password, country, and daily budget that I need to expand. So I need to create some page object for this page to interact with the web page. And the page object for this, I have here a count page. And what I have here? I have some find elements to the web page. I have that email input. So I need to show how I can find this input in the web page. Here's from the ID attribute on the HTML. I can use a lot of different attributes using Selenium. And I have how I can fill, or I can click, or I can do some interactions. I need to create these methods to interact with any of elements on the web page. I also need to create some strategy to make it available for all the tests, and don't use, like we said, like we call it the driver itself, that's the Selenium class to instantiate the browsers, to not put it in the test, but to maintain it on the page object itself. So I have an abstract page object that I have here to do some page factory that have a method called initElements. This page factor is a class that will see my page object and see if I have some elements that I need to interact. If yes, we are able to find this when I use it, when I use the methods to like fill password. Then you use the element password, and you're gonna initialize this element to be able to the test using it during the execution. So I just need to create, I can create inside any page object, but using the inheritance, I can create an abstract class and extend this class inside any page object. And the follow item is the loading strategy. All the time we're gonna test some page, we need to wait some time, amount of time, to wait for the certain events, most related to the asynchronous requests like Ajax. And the bad ways to do this, it's like a pause. In Java, it's a thread sleep, isn't it? I can put a thread sleep and wait, pause the thread, pause the execution during 10 seconds, and after I can do something. But if the element's available 1 second after, I need to wait the whole 10 seconds to interact with the web page. It's a bad practice. Like use the implicitly wait. It's a functionality inside the Selenium, inside a lot of testing frameworks, that we need to just put one line in your code and magically it will wait for anything for a certain amount of time. It's not so good because you want to know in your code which action will take time. So if you need to refactor your code, you don't know where it takes some time and where it's not. And what's the good points applying load strategy? First one is using implicitly wait. Implicitly wait is a strategy you can see in your code which element will take time, and you need to put it in the explicit way inside your code. But if you're using page objects with page factor pattern, you can use the Ajax locator element. And this Ajax locator element, you do the same thing the explicit waits do, but one time per class. And you don't need to write a lot of code, just putting some explicit waits in your code. For this strategy, I also have on the abstract page factory class this part call it Ajax element locator factory that will wait for any actions during my input password or click on a button. We wait for amount of time that I configure in the timeout inside my configuration file. So it's a smart use of the element location, doing some loading strategies. If you don't use Selenium, or if you don't use page factors, you can use the explicitly waits as well. Okay. And the last thing here about page objects is about the FLUENT interface. FLUENT interface creates methods for chaining some actions or perform series of actions to make the code more readable. So I have here a test for choosing a menu for selecting charts in the Flight Emirates web page. So it's not in a FLUENT interface, but it's readable, isn't it? I can understand what I'm doing here. But if I need to put in a FLUENT interface, I can just make just one line to chain these methods and try to show in the test how the user is gonna do in chained actions. To do this, I need just to modify one thing in my page objects. That is, instead of using of void methods, I can, it's account page, I can return the page object itself, that is account page, and after return this. So you'll be able to chain all these methods and put in the more fluent way. It's just a choice. You can put with fluent interface or without. It's just your choice to make more readable or not. Okay?
So one of the most important parts to analyze problems during the test execution is log the exceptions in a file will enable the analysis of the root cause. And general reports like the total number of the executions and status and or evidence of the test execution can help us to analyze errors and create executive reports.
One of the things that we just don't put in your testing architecture is generate logs, files for the exception logs, isn't it? So we need to using this strategy to save all the exception in a log file, so we can understand which common actions we applying or showing some errors during this test execution. And we can have a lot of different type of errors, like assertion errors, timeouts, locator errors, or some exceptions in your base architecture. So we need to just, this is really simple. We just need in all failed methods and all failed actions, we need to just put one line about logging exceptions. In Java, it's really easy. We have a lot of frameworks to do this. I'm using here the the log4j to create this, and I have some points that I can apply this. I don't have this in the base on the base test, because in the base test I have another. I don't need to apply the log management here, because I know that with some tests gonna fail, I will see this on the listener during the test lifecycle. It makes sense. If I have a listener that watching the test lifecycle, I just need to go there and see if I have some error. And if I have some test failure, I have a method here that will log some errors, log the exception, the class name, and the browser information, and we'll take a screenshot from a test and attach in the report file that I have. But here, the point here is just create an exception log for all the tests, because it's really small here. I can have a lot of exceptions that can show us some common errors during the execution, and I can just apply a root cause analysis to try to figure out which error is it and fix it in a fast way. Okay. And we can also use, you have some many teams using some base architecture. You can use some tools or some approach like Elasticsearch to analyze more than one log to try to correlate which one is most offended to our test architecture, or which more it's occurring during the whole execution, and we can use the Grafana or Kibana just to show all the data to this correlation data to try to make some actions with these log exceptions. The next thing is generate some reports that stakeholders will see. Sometimes some stakeholders need to be how the test was executed and if it's all good or not. So we have some reports, some approaches that we can using the XUnit files and attach these files to your CI/CD and rapidly see all the results. Most of the Java frameworks generate this XML file. This related to JUnit file, JUnit generation file for the whole execution, and we can apply some other approach to create some executive reports. Here we are using extent reports to do that. That's more cute reports to show for stakeholders, but it can show more things that we can go and see if the test is really executed and which time, and see some screenshots for the errors. Here I have a report with some errors. So always red in the report, like put in the light array here. And I have the total time of execution on some items, and I have here this test failed. So I can see the details of this failed method, the failed test, and I can see also the time that the error occurred in the web page and take screenshots to show after as evidence of the error. I can do as well this for the evidence of the whole test execution, step by step if I need, but it's a good practice just to log these screenshots or just errors when that's gonna fail. Okay?
The data generation will reduce the amount of time to test maintenance. Fakes will generate non-sensitive data, and static dynamic generation will create the dynamic data.
I have a lot of problems with data generation. I think you too, because we all the time need to create some new data to run all the tests. Okay, the first thing we can apply is the using of fakes. The fakes ability to create some data. For me, it's some non-sensitive data to our test, without the necessity of change all the tests or the data during each test execution. We have a lot of tools to apply as some fakers data. I think the one of the famous is Java Faker. Here in this code snippet, I have a faker generating some data in Brazilian Portuguese language with the full name, full address, email address, credit card number, and a birthday date. So I can generate many of items, many of data without changing my code. If it's non-sensitive data, I can use this as well. I don't need to all the time try to to make the tests, to change the tests to any data. But sometimes we need, we have this necessity to create some data that will change the testing aspect or the test execution. I'm working at a bank, so the bank account is one of the most used data to try to do some tests, like I need an account with $100 with balance, I need an account with no balance, I need an account with credit card, some investments, or some aspects. I can do it, create some static or dynamic strategy. In a dynamic strategy, I can use a data pool, a data pool. A data pool may be a CSV file or JSON file or YAML file, some file that needs to apply to grab this information and put in your test. Instead of change the code itself, you can change external file, okay? Or you can use an approach called dynamic generation. I'm applying a dynamic generation doing some queries inside a database to bring some different accounts. So I don't need to change also the code. I just need to have a database with the whole aspect of the data and consume from them. For this one, for this dynamic generation, I all the time create some DSL to make it easier to get this data from the database. So I have here just a snippet of the code. If I need to generate some account, I have here a builder that generates, oh gosh, with an account type as individual, with the edgings, without restriction, and I need to build this. I need to get this information. Or I can get some account with negative balance, or I can get some account from corporate applicants for a corporate and with injury as a restriction. So it makes more easy to generate some data without all the time changing your code base or testing script, okay?
So the parallelism will reduce the test execution time. Parallelism run many tests at the same time in a chosen target, and a grid and an autoscale strategy will speed up the test execution.
Who are using parallelism during the test execution? Here, just one, 3, 4, 5. A few of people. Parallelism under test is the ability to execute some tests in different conditions. For web test automation, it's browsers. I can apply it in a mobile. I can apply it in whatever I can in the front end, or different tests at the same time. I have at least 3 different ways to do with Java. The first one, I can apply I can use Maven Surefire plugin, but I need to configure in the POM XML how many threads I need to execute in parallel. It's really easy, but I have also a class called Parallel Computer on JUnit 4 that I can use, but I need to create this type of parallelism with the code. I need to extend this Parallel Computer class and make more way to create these tests in parallel. And I have also the test NG, and I can apply the parallelism with test NG with the test suites that are XML. There is XML files that I can say that in the configuring this XML file. Just I need to parallelism with test, with class, or some other aspects in my test. So we're gonna use test.ng to do that. But first, we need to show to you, we need to learn how we can put it in with a lot of machines. We have an aspect that we call it a grid, and have a grid schema with a hub. A hub will be the machine that will control all the nodes, all the operational systems with some browsers. And the node itself is the operations system with the browsers, like Linux or Mac with browser like Chrome, like Firefox. And in my test, my test script, I need to send some capabilities. These capabilities, I need to execute a test on Mac OS in a Safari target. So the hub will gonna understand these capabilities and send to the proper node. I can do it just in a singular way, just one script and one target, but I can apply this in a parallel way, like send tests for any browser that you have inside any nodes. I can do that, or I can do run this script in whole browsers, in whole Google Chrome browsers. I can do this. I can do it as well. Okay, and we have some ways to generate this infrastructure, these ways to create this grid. The first one is local. We can use our local infrastructure, and it can be the bare metal desktop or virtual machines to do that. We also have the using of the cloud infrastructure to create some virtual machines on the cloud, and we can use containers as well to do it locally or on the cloud, and we can benefit for the using or support of orchestration using containers. So it's maybe a better way to create some nodes for test execution. Okay. To do this parallelism with TestNG, it's really easy, but there's a small trick to do. I have here an XML file. That's my test suite for TestNG with some test executions like that test book run test. But I have here a parameter called browser with Chrome. I have the same test with another parameter called Firefox. So I'm gonna run the same test in a Firefox browser and a Google Chrome browser, okay? But to give this information for a script, I need to go through my base test, and I just need associate that parameter, that is browser, to my preconditional methods, and get this browser information and send to the driver factory, and make the driver factory create this for me, okay? And I can use this in parallel way because I'm using some strategy that not inside the test, it's outside the test, and can be has many browsers I can create, I can do. And the next aspect of this is create the autoscale strategy. When you have a grid schema, this grid schema don't scale because I have just one Windows, one macOS, and one Linux node. If I have 100 tests to execute, I will create a queue, isn't it? Because I need to wait for the test finished in the certain browser to execute the next one, and so on. And it can take a lot of time to executing all the automated tests. But I can I can apply some strategies using containers to create some approach to autoscale. The first one, we can use the Selenium containers that is maintained by the Selenium team, that has containers for each aspect of the grid. They have a container for the hub, one container for Chrome, one container for Firefox. But this autoscale strategy will be based on the hardware utilization, like memory or like some process utilization, okay? So it's really hard to tell, to script. If you have 100 tests coming, create 100 containers. I need to do some in-house developments to do this. But with Selenium containers, Selenium is containers that use the base of Selenium containers and use a single container called El Galo that provides a lot of features like VNC, video recording, dashboard. It's just one container for the whole thing. The one container for Hub, for Chrome, and for Firefox, okay? And I can do the autoscale in containers based on the number of the tests. And now, if I have 100 tests to be executed, Selenium will create 100 of containers for me. And after the execution, Selenium will kill 100 of containers for me. It's a Lasky outscale up and outscale down. So this approach can speed up your tests in an easier way. Here, my approach to use Selenium is just putting one by one. If I have one test, I will create one container. In Selenium, I can do it when I start Selenium, we start the container, through this max test sessions is one. It's meant to be one by one. If I put 2 or 3, it's a 3 tests per container, okay? And I have here just 2 containers with Firefox and Chrome, ready for some any tests. And I have my test suite with 4 tests, okay? So what's gonna happen here? The 2 available containers will execute the tests, and I have 2 more tests coming, isn't it? Selenium will create 2 more containers to execute these other 2 tests. I will go through to the terminal. And if I refresh, I can see it's with the VNC available here. I can see the browsers coming up and executing these tests. But I have more 2 tests, isn't it? I just need to wait for a certain amount of time to Selenium create and scale this container to execute this browser. So one more time. Selenium takes some time, 30 to 1 minute to scale these containers. And supposed to be now. Now I have the 4 containers for applying my testing payloads for my whole testing. So I don't need to wait for a certain time to wait for the browser execution, the browser to be available to execute more tests. If I have 100 tests, I can my amount of time will be the most slowing tests in my test infrastructure. So if I had a test that take 1 minute and I need to execute this test in the whole browser in the 3 different browsers, it's gonna take you just 1 minute, not 3 minutes, because it'd be outscale through the containers. Okay. And the last thing,
pipeline is a concept that divides all actions during the software lifecycle. In test automation is the different types of tests that will be executed on a target website.
I know, guys, that you have a pipeline strategy during your development, but sometimes we forgot to put some testing actions in your pipeline, isn't it? And for web test automation, we need to put a pipe or a strategy in a pipeline to apply this, to execute the testing during the pipeline, and at least we need to create smoke testing strategy. The smoke test is the most important test in a business perspective. Like if I need to sell tickets for a theater, for a concert, I need to just run this test to make my whole business available, isn't it? I need to just run this test all the time. The second approach after the smoke test is execute all the acceptance tests. That is the most used user scenarios on our web application. And the last one is running some functional tests that I can assure that the critical functionality is gonna continue working during my whole execution. For the smoke test, we need to execute this for each build, each development build, because if I had some problems in cell tickets, I need to show this error as soon as possible to make it available to maintain our business running, isn't it? But for acceptance tests and functional tests, it's our determination. I can run in which builds and during one time per day and the weekends. And we need to run this in the parallel way like we see before, okay? So guys, thank you so much. We have this presentation and this project, this basic project in this QR code. If QR code doesn't work for yourself through your cell phone, we have the link, just take a picture. We have our contacts here as well. And we are here during the whole event to try to exchange experience, okay? Thank you guys. Bye-bye.